Today we are going to discuss some details about the organic compounds containing oxygen. This is in the form of question and answers because I already learned few things in one of the earlier sessions about these organic compounds containing oxygen. Now, the first question is actually given in the form of a multiple choice question where 4 options are given, out of which we have to choose the best option. Now, which of the following compounds can be dehydrated easily? The question itself says dehydration. Dehydration means it relates to alcohols. So alcohols undergo dehydration to produce an olefin, and alkyl halides undergo dehydrohalogenation to produce olefin. Product formed is an olefin, but the alcohols undergo olefin, and alcohol undergo dehydration to give rise to the olefin. When you look at this compound, you will find there are 3 compounds which are given as alcohol. Of course, this does not undergo dehydration because this is a ketone. There is no OH group found in this compound. Obviously, this is ruled out. So we have to decide between A, B and D. Now, between A, B and D, whenever an alcohol undergoes dehydration, we call it as 1,2 elimination or beta elimination. In other words, a hydrogen in the beta position with respect to this OH group. With respect to the OH group only we count. So with respect to the OH group, this is the beta hydrogen, this is the beta hydrogen. With respect to this OH group, this is the beta hydrogen, this is the beta hydrogen. And with respect to this OH group, this is the beta hydrogen and this is the beta hydrogen. The question is, all the 3 contain beta hydrogens, which will undergo easily? That is the question. Therefore, when we look at that compounds, which hydrogen can be easily removed? That means a weak bond between carbon and hydrogen will take away that beta hydrogen. Now let us look one after the other. We will leave first A, we will come to B. There is some reason for leaving A first. Then look at B, we find there are 2 beta hydrogens. So if this beta hydrogen is lost, it will give a terminal olefin, whereas this beta hydrogen is lost, it will give an internal olefin. Probably this beta hydrogen is 1. Then look at the other options and then we will decide which is the best option. We have already removed the option C from this, so let us not look into this. Now come to D. This OH, they also contains the 2 beta hydrogens, so this again will give rise to a terminal olefin, and this will give rise to an internal olefin. Now consider this A. When we consider A, this has an advantage over B and D. As we look at it, we find here again we have 2 beta hydrogens, one is here, the other is here. But what is the speciality of this hydrogen? This is next to a carbonyl group which is electron withdrawing. A carbonyl group is an electron withdrawing, and therefore of the remaining 3, C is ruled out. Among between A, B and D, A is the best choice because A undergoes, all of them will undergo the elimination. There is no problem about it. All of them will undergo the elimination or dehydration to give rise to the olefins. But which will undergo more easily or more readily? That is the question that is asked. Therefore, on the basis of the question, the best answer we can give for this question is A, because this hydrogen OH and this hydrogen will be lost and an olefin will be produced at this point because this hydrogen is next to the carbonyl group which is electron withdrawing nature. Therefore, the correct answer for this question is A.